Good afternoon, everybody. Thank you so much for joining us for today's London Java Community Lightning Talks. For those of you who don't know, my name is Abby. I work with Barry Cranford, who's the founder of the LJC, and I have the privilege of hosting today's event. For those of you who don't know as well, the LJC is just one of the 15 to 17 communities now run by RecWorks. We are a tech recruitment company with a massive, massive difference. So as a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to teach or share their knowledge, we are happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run over 700 events for engineers and developers, students, graduates, and CTOs. We have run conferences, lightning talks, hackathons, mingles, all sorts. In January of this year, we made our 4,000th introduction through our Meet a Mentor program, which is one of our communities. They're all completely free. We're really excited to see where that's going to go next as well and get our 5,000th introduction through our Meet a Mentor program. We're really looking forward to that. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our communities, please do get in touch with myself, Barry, or Helen Lewis if you know her, and we can go from there. The recording of today's session will be on YouTube by usually middle of next week, I would expect. I'll put the link in the chat later on. And we have 4 amazing lightning speakers to hear from today. I'm really excited to welcome you all. And we're going to start off with Alex. I'm not even going to try to attempt to read your title out. You're going to do that bit yourself for me. Thanks.
Hi folks, yes, so I'm doing a book review here, and the title of the book is Simplifying Data Engineering and Analytics with Delta. And I'll explain roughly what that means later on. I'm mostly a data engineer, and this talk is mostly of interest to people who are involved in data engineering. We'll explain a bit more later on. Okay, right, so this is the book. I should say the usual disclaimer of I've got a PDF copy of this given to me for book review purposes. It's published by Pact. I've got the URL here in case you want to find it out later on. This URL will appear at the end of the talk as well. What more can I tell you? So a little bit of a hint on the cover. It's got a foreword by somebody from Databricks, and this technology is very Databricks heavy. Databricks is a company that focuses on Spark and providing Spark as a service to you. Let's see, so who am I? Alex Plintock. I've had 30 years in the software industry. Last 10 years or so, I've been designing and implementing big data systems. Mostly that's been using the Cloudera and Hortonworks technology, not Databricks. So this is a bit of a new thing for me. I knew something about Delta, but not everything. Okay, so who is this book for? Well, people who are new to data engineering, if you need to understand more about how you're getting data from one place to another so that it can be useful, then the first 50 or so pages are for you, because it looks at the high level stuff. But really, I think data engineers who already use Spark are the target market. And if you need a particular new tool because you have data that updates over time, then that will be the rest of the topic for you. I've included a whole bunch of diagrams and figures in this talk, in this review, and they're not necessarily here to explain everything to you straight away. They're more to give you a flavor of what's actually in the book. So this is one of the most famous diagrams or concepts in big data. So at the top, you typically have your batch processes where you typically say do analytics overnight, you load up all your data, do your analytics and save some pre-computed queries. And that works fine if all you're doing is updating every day or so. Underneath is the stream processing, and that would basically take all the data that's collected in that day or in the last hour and provide an alternative way of storing what's been happening recently. The problem was, how do you write that data? Historically, we use Parquet. Nowadays, you use something else for the streaming. Now, what Delta is aimed at is by combining these two into a single streaming layer. And because it can't use Parquet to update all the time, it uses this new thing called Delta, which is basically Parquet files with lots and lots of changes. I'm going to skip over this diagram. The main point I was trying to describe here is that that part of Delta is that it provides ACID support. If you're used to databases, relational databases, then that's something straightforward that you'd expect, but isn't always the case for big data problems. So what is a Delta table? So the point behind this diagram from the book is that most of the data is actually stored in Parquet plus whatever's changed. So you have most of your data in the left on the data files, and then you've got something that stores the changes to that. And rather than changing the Parquet every time there's a new write, all you're doing is you're writing a new change into that Delta table. That makes things a lot quicker. This is what it looks like on disk. I kind of included this to show you one important thing. Well, there's two important things. So one is that although it's at one table, it's actually lots of files. But also the other most important thing is if you happen to be stumbling across this and see, oh, in this Delta table, I've got this log files, don't delete them. Don't assume that just because they have log in the name, that means that's something you can delete. In reality, that's actually the actual commits that have happened over time. So that is real data. So whatever you do, don't have a rule that just says delete anything that's got log at the end of the thing. I'm not going to go through the detail of this code. The point of showing it to you is to say that this is traditional Spark. So if you're familiar with Spark, then this is almost identical to doing the same sort of thing with Parquet. If we move on to a bit of another example, this is demonstrating Spark in a bit more complexity. I think one of the important things to demonstrate here is that you don't have, as you write the data, you don't have to perform any kind of metadata reload or refresh of the thing, which is quite common with Parquet. And that's one of the main selling points of this format. The other point is that what you can do is you can actually add to these Delta tables as you go. It's not that it's fixed. And here's an example of a merge, which you just can't do with Parquet. I'm sorry if I'm zipping through these. I need to give you the verdict. I think the book is good. It's got lots of really useful information. It seems accurate, but it does focus purely on Delta. It doesn't really compare it to the other similar technologies. Apache Iceberg is the most important one. And there's not enough high-level explanation to make it suitable for the managers. So I kind of think it's for a data engineer who's already familiar with those things. So you'll probably find you're going to just skip the first 50 pages or so. And if you are a big data engineer and you need to record changes as they happen, then Delta might be the right format for you. This book might be the right thing to learn from, but investigate Apache Iceberg as well. So final slide. There comes that URL again. I told you that the book will be available towards the end of this month. If you are watching this video in August or after August, then I may have more stuff. So check my LinkedIn for a more up-to-date version. And of course, Amazon is not the only place you can get this. I'm sure that you can get packed books from elsewhere. So that was simplifying data engineering and analytics with Delta. Thank you very much. Any questions?
How did you get through that so quickly? That was my question.
Well, I've got a timer, and I realized that several slides were totally unnecessary. So, I mean, particularly
well, thank you for being honest. That's great.
Well, I think that, to be honest, that the lots of the Spark code would be of interest to somebody who's familiar with Spark, and they just look at it and say, "Oh yeah, I see that. That's familiar to me," and everybody else wouldn't really care. So it was mostly just to give people a flavour of what it is. If anybody else has code, don't feel like you have to do it at the same speed as that. In fact, I was far too hurry. I was in a bit of a hurry.
Hello.
Cool. Hello.
I have a question.
Go
Hi,
for it.
Alex. It's Nikita. Can you recommend any open source project to go together with this book?
That's a very good question. I mean, so what I didn't say, which is quite important, is that Delta was created by Databricks as closed source, and is itself, it's released Delta as an open source project. So it lags a bit behind the Databricks' closed source Delta. I think, though, that basically, because it's fundamentally just a storage type, you could use it for almost anything where you're using a big data type environment. So if you are already thinking of Spark for some problem, then this might be a typical storage mechanism for you. Sorry, I couldn't be more precise on that one. Okay. Thank you very much. Is anybody else? Abby, I think I'm going to pass back to you.
Take that as a no. Yeah, that's absolutely
Thank you very much.
fine. Thank you, Alex. So next up, we have Soumya. Over to you, Soumya.
Thank you. I'll start sharing my screen. Yeah. I hope you can see my slides again, right? Yeah. So starting, I'll introduce myself. My name is Soumya, and I was an ex-teacher of computer science. I had worked for around 5 years as a teacher. And after quitting my job, I started working as a freelance trainer. Basically, I was a Python trainer doing for a couple of companies. And I'm also trying to switch to the industry. I'm an ML enthusiast, and I recently finished an internship. So we were building micro products using a bit of machine learning, web scraping, natural language processing. And that's when I found, I learned about Streamlit and instantly loved it. So I thought this is my first talk, and I'll talk about Streamlit. So what is Streamlit? Streamlit is, many of you may know, it's a quick way to turn your data scripts into web applications. So in their website itself, they say it's an app framework for data scientists and ML engineers. Why? Because when you are building your web, data applications or data scripts, it's easy to turn it into web apps. If you think about Django or Flask, such frameworks, you have to get into the complexities of sending the HTTP request and the front end, again placing HTML, CSS, placing that button in the center. That's a difficult task for especially data scientists and data engineers. So Streamlit helps you there to avoid that and focus on your algorithms, maybe. Yeah, and it's also easy to deploy and share your Streamlit apps. You can do it via Streamlit Cloud itself. So now I thought I'll give a simple demo of how you can turn your scripts into a simple web app using Streamlit quickly. So please tell me if you can't see my code. Yeah, I think you can, right? I have a script here. I am importing some Indeed code get jobs. So get jobs is a function that I've defined in a file called indeed.py, which I created here with some jobs from Indeed website, and I'm just printing it here. Okay, print get jobs, and I'm searching for, and I'm passing another argument as a number of days uh, before, like 7 days ago the job was posted, so the number of days when the job was posted. So when I'm running this code, it returns a list of dictionaries which will give you the title, company, day when it was posted, and the location of the job. So this is a simple Python script which we are going to turn into a web application. So I have imported Streamlit also, and we'll be using Panda, so I just imported it, and I've commented all the code so that I don't have to code. We don't have time for that. So first you just do a st.title. I'm just giving a title, Streamlit, using Streamlit title method, and just I go back and just clear this. And you can run your Streamlit application using Streamlit run main.py. I forgot to tell to install Streamlit using pip install, like any Python library. So when I'm running this, it will open your browser and Streamlit will be open. Okay, I have not saved this. When you save it, you go back. Okay, and something wrong. Give me a second. Okay. All right. Yeah, so your title appears here. This is your simple Hello World application in Streamlit. And I just wanted to create this job search assistant. I'm going just quickly, I'm not aware of the time. So I want to pass that, search term, which is Python, and the number of days when the job was published. So I'm taking inputs from the user. So the widgets in Streamlit, they are treated as variables. You can just give st.text input and you can give a message. So whatever the user enter here will go to search term, and you can, I'm also adding a slider where the user will be allowed to, choose the number of days. Again, that will be treated as a variable and it will go to the, published days. When I save this and go back, here it shows source file changed and rerun. So you can give always rerun. So whenever you make changes in your code, always this will be updated. Okay, and the Streamlit always run from top to bottom manner. Whenever you update your code, that's what happens. So that's it. I can just slide and select the days, and I can just give the input, and I'm going to add one button to just trigger that function call. So I'm just adding if st.button, and I give a label again for the button. This is a Boolean. This returns a Boolean value like true or false. If it's true, the if condition, whatever is inside if that runs. Yeah, so when if button dot find is clicked, you are making that same function calls with these two input values, and that will return, as we have seen, a list of dictionaries. And what I'm doing is I'm converting that list of dictionaries into a data frame using pandas. And in Streamlit, you can display pandas data frame easily using st.data frame method. So done. Now let's go back to this, and I'm searching for Python posted like in last maybe 7 days. Find will take time. Yeah, so that's the data frame display. It's a data frame, not just a table. You can display table using Plotly, or you can integrate that also. But the data frame, the beauty of data frame is you can just sort it by clicking. It's interactive data frame, and you can use other Streamlit components to make it more interactive. You can highlight, you can select and deselect columns, group it using components in Streamlit, which I'm not showing now. So that's a small demo. That small script is converted to a beautiful web app in just 6 lines of code using Streamlit. That's the reason why I love Streamlit. And you can also set the themes, here in settings. You can just use light or dark themes in Streamlit. You can even customize themes by configuring it in a config file. So that's it. Of course, it's not as powerful as Django or Flask. You cannot do everything that you do in Django or Flask using Streamlit. But then if you are a data scientist, you want to make a quick web app, Streamlit is one way to go. That's it. Thank you. And you can connect me through LinkedIn or GitHub. Thanks a lot for the opportunity. I'll stop.
Fantastic. Thank you, Soumya. That was fascinating. Does anybody have any questions? Go on, Alex.
Yes.
Oh, and Robert, go for it.
Robert, go for it. If you
Right. Okay. Cheers. Yeah. Just a quick one. So when you uploaded the script changes to the server, to the service, to the web service, was the service actually get? Did the service actually get restarted?
It automatically, when you save it, you can just give always rerun in the browser and it will automatically get updated. The Streamlit will run from top to bottom, the whole application. That's what.
Yeah, the service, did the service get rebooted? I mean, there's a difference with between rebooting and not rebooting when you uploaded the changes. Was the service did the service get rebooted?
I think so. Yeah, it gets rebooted. That's what I'm not very sure, 100% sure, but that's what's happening, I guess.
Okay, because it's in the industry sometimes people really care about rebooting in the in lifetime. So okay, good to know this. Thanks for your interesting talk.
Yeah, thank you. I will also confirm it. I'm not very sure, but thank you.
Okay, I think that's important in the industry.
Yeah, thank you.
Thanks.
Can I ask my question if we have time? Cool.
Yeah.
Hello, Soumya.
Hi.
Very well done for doing a live demo in the middle of a talk. It's very impressive. Can I ask, what sort of use cases do you find this is suitable for? Because you said that it doesn't do everything that you could develop with a Flask or Django app. But obviously you're doing it very quickly with just 6 lines of code. So do you see it as like just a developer tool for yourself, or what sort of things do you recommend it for?
It helps to create like dashboards and visualizations. That's what I used it for. So you can go to the gallery of I'm not sharing the screen again, but then you can search for gallery in Streamlit website. You will see a couple of applications that are done by the use cases. You can see it there in the Streamlit gallery. So when I was doing the internship, we have developed like a tweet analyzer where you enter a person's Twitter ID and get all kind of visualizations and data about that person. So, and then you can even host it in Streamlit Cloud or even in Heroku. So that's mainly for dashboards. But if you want a application where you have to log in and create more secure and with authorization and all, I'm not very sure if Streamlit will do. They have recently launched multi-page apps, but it's still developing, I guess.
Okay, so what I'm hearing is it's for very simple stuff that you want done quickly, and as Robert was hinting, it's not necessarily the most efficient thing in the world, but it's nice and simple and quick to develop, which is good.
That's
nice.
What I
Thank you very much.
Thank you.
Last but not least, as by any means, we have Sudarsan.
I hope you can hear me, guys, and you can see the first screen. That is just the title slide. Okay. So we're going to talk about robust API design in 5 minutes, or thereabouts, mostly thereabouts. So before I started this talk, I had this really big title. The actual title is supposed to be writing secure, performant, self-documenting, accurate APIs using strong static typing in Java in 5 minutes. So I just noticed I ran out of title space and I'm also down to 4 minutes. So now let's look at robust API design because it's a simplified version of the title. So I'm Sudarshan Balaji, and you can find me on Twitter or on GitHub at those links. They're not links, but those are my IDs. So I'm a solution consultant at Sahaj.ai. We are basically an organization that works on bespoke software and data engineering solutions for other organizations which require them because they have like complex problems. That's just a fancy way of saying I solve problems using technology. And coming back to robust API design. So what is robust API design? So robust API design is basically designing APIs that are accurate, self-documenting, APIs that are secure, and those that prevent mistakes. To put it simply, it's robust APIs makes impossible things impossible while making it very clear what's possible. That's what I mean by robust API designs. We need to know how to make them. So let's take a small example of tic-tac-toe or noughts and crosses. This is a sample image to show what that is like. Now we're going to jump over code. I hope I can actually do justice with the time I have. So this is basically me trying to write some API in Java. And because it's an API, we're mostly not going to drill into like classes or implementations. We're just going to talk at interface level. Enums are like special, even though they are like implementations themselves. You can just treat them as like values limited to certain static number, like certain static values. So like they're also part of the interface. They're just interface for the data. So here we have like 2 players, X and O. There are only 2 possible players in the tic-tac-toe game. And here I'm saying there are 9 positions in the 3x3 board. So there's top left, top center, top right, mid left, mid center, mid right, bottom left, bottom center, and bottom right. So using these 2, we're trying to create an interface for the game. And we obviously need a player who's like the current player. So there's going to be a get on the game that's going to return a player. And then we're going to have a function called play. I mean, this is what people normally come up with. So when I say void play, it takes a player and a position, and the game basically provides you this way to play. So I think this has to be small. I'm so sorry. But if this is our API, what does it tell us? How is it self-documenting? Is it accurate? Is it secure? So we're just going to examine what problems there are in this kind of an API and kind of change it a little bit. So the first thing is, when I see this function called void play, I don't know what it does. Does it send an email? Does it print things to the screen? I don't know. Just by looking at the name called play, I can't assume what it does. Does it change the state of the game? I have no idea. So I think we can do one better. So we're going to write like game v2. I've written the code before, so we don't have to go through it again. So here we are saying that there's still a play function, but it returns a new instance of game v2, or it basically returns another interface of this. What I mean by that is there's going to be something that happens in the game. And by returning the same interface, I'm basically communicating that the play function, once it's done with its work, is basically going to return you like a new game. That basically tells you that the game changes. And it's up to you to decide whether to use the changed game or not. So there's a resulting game. Like whenever you play a move, there's a resulting game, right? What's the other problem? For example, if I take this API, the player X can play 2 moves in a row, right? I can basically say new game or whatever, and say dot play player.x comma position something, and I can then say dot play player.x comma position something else. So I'm able to play 2 games in a row, 2 moves with the same player in a row, and I want to stop that from happening. So we can also come up with a slightly better API, and we're going to now say, oh, you can actually decide who the player is, because in the previous version, we're basically saying get the player who's supposed to play now and pass the player back to me, which is like really weird. What if they pass me another player and don't pass me the current player, right? So we're just going to change the API and say, you can only get the player, but you can't pass me the player. So the game already knows who the current player is. And when you return like a new game, that game will also know who the current player is, and you can never change who the current player is. So there's no way to make like 2 X moves in a row, because the game decides whether it's X playing right now or Y playing right now. So then we are left with another problem. So for example, what if X already played on the top left? Once we play, O should not be allowed to play on the top left again, right? Which means the place is already taken, the position is already taken, so you're not allowed to play. But this API is not really communicating that. So how do we communicate that? So I think we need something called a move to communicate this effectively. So basically, we need moves which are played on the game. We didn't create such an abstraction initially, and which is why it's like harder to think about it. So we can come up with a game v3, game v4, where we are saying we still have a get player, but a game also has like get moves, and it's going to return a map of position to move. It's the same as having another interface where you have an optional move, get move for a position. So basically, at every game, you have a map of position to moves, and then you try to get which move. And the move itself doesn't take any inputs, so it just makes a move and returns a new game. So what's the difference? So for example, there are a few ways I can do this. For example, I can have position and move, position and player inside the move, but it doesn't communicate the same thing. For example, if I remove the player from here, and actually put a player here, so saying the move itself has a player. What it communicates is that when I call this move, there can be moves played by two different people, because different move instances may have different players. But at the point in the game, all the moves belong to one single player, right? So the player doesn't change for every move. That's why that cannot be the interface, right? So that's what we're communicating with this API, that all these moves belong to the single player, right? What's the other thing? We could have also done something like list of moves instead of this map, right? So when I say list of get moves, and I go through them one by one, and every move can also have a position. So I can again say, oh, there's a position and get position. There's this API. So every move will have its own position, and I can just get a list of moves. The problem with the list of moves, firstly, is that it doesn't guarantee that they are unique. So maybe I can say a set of moves, and then it makes it unique. Like there are no duplicate moves in the game to be played. The other problem that this has is that it doesn't guarantee that the moves all belong to different positions, right? I can have a set of moves, but each of them can have the same position, but they can have different make functions, which doesn't make them like really unique. So when I say map a position to move, what the API communicates is that moves are always attached to some position, and they're unique on position. Like there can be no two moves which can take the same position. That's what it's communicating with just the interface. Like we have not written any code. So that's why we can't have this kind of an API. So we basically land here. And it's the same as this other API where we say, instead of this get moves map, we can also say get move, you give me a position at this game, and I'll return you an optional of move, which means if the move exists at that position, I'm going to give you a move. Otherwise, I'm not going to give you a move, right? Both of these are equivalent because in the map, you basically have this key value pair. Here, you're just representing this map itself as a function. So they are both equivalent, right? I don't know how much time I have left. So let me look at one more small problem. Here we want to say, once you make a move, you should be able to undo a move. But until you made the first move, there's no way to undo a move. So how do we want to communicate that? So basically, we need something called undoable. So I'm going to create some interface called undoable, which is going to take a game, v5. I'm going to create the next version of game. And it's going to return the game. So it has one method. It extends the game v5. And every time you have an undoable, it also has a method called undo. But how do you know that only after you play a move, you get an undo? So notice that if I go to, if I create a game v5, there's no undo here, but it's a map of position to move v2. So let's look at move v2. What move v2 does is the same, but except instead of returning a game before, it now returns an undoable, which means that every time you make a move, you get an undoable back. So you know that you can call undo, right? But if you've not made a move, which is just a game v5 interface, it doesn't have an undo function, so you can't call undo, right? So we just expressed a lot of ideas in this, and I want to go back to the slide and see how did we do. Did we make it more self-documenting? Did we make it more accurate? Did we make it more secure? So how do we make it more secure? To just look at some of these, we made it more accurate in the sense that we established that the same player cannot move twice. A position which is already occupied cannot be played upon. As in, you can't play wherever you want. You can only play in a certain limited number of positions. It's very clearly documented in the API. You can't undo without making a move. That was clearly documented. When you make a move, the game itself changes. That was clearly documented. So the more accurate the API gets, the more self-documenting it becomes without writing any implementation code, right? And it also prevents mistakes. Like nobody can play as two moves as X back-to-back because that's a mistake. And we prevented that mistake by just writing a better API. Right? It's also more secure because invalid users can't make moves that don't belong to them. Players can't make moves that are not possible. So it's just more secure. You don't give people functions where they can call it with invalid arguments, and then you take some runtime, and then you throw exceptions. You just make it impossible for people to call functions that are not required for them. Make it impossible for people to call functions that are not possible to call in the first place. So let me know what you think of whatever we did right now. We can have a little bit more fun with tic-tac-toe. So we can try to show that by the API that there are no draws possible in the game before there are 9 moves that have been played. That's the only way to have a draw. It's also impossible to win the game before 5 moves. And we can also expose that in just the API without actually writing implementation code. It's also impossible to play further after a game is won or drawn. So that also we could bake it into the API. And all of this could just be understood from the API instead of looking at the implementation. So these are some few things that I came up with. Try them out. Do you have any questions?
Any questions? Yeah, go for it.
Oh, thanks for your talk again. Did you consider domain-driven design before in your the way you coded the API? And so the way I see that might change. What you did is you would introduce a player would say, I'd like to play this game, and a game player would be returned, and then the API will be driven from that.
Mm-hmm. That's kind of a different way of looking at it. So in this case, even players, they don't have any implementation detail, and we're just trying to avoid players being anything more than just names, because they don't do anything. But we can construct a domain sensitive API on top of this, where it's impossible to make impossible things with a core API. But if you want to expose like player instances which themselves have the ability to display UI or make moves, those are abstractions that can be built on top of this. So the idea is to not have like really open abstractions, but to actually restrict the abstractions to what will only be legal, in a sense, like what is illegal, what is impossible.
Sure, understood.
Like completely locked down, but without the implementation. We can build other kinds of UIs or other interfaces on top of this, which are built differently, but it's impossible to make mistakes by consuming this API.
Sure.
It's more about robustness than anything else.
Thanks. Cheers.
Excellent. Any other questions for Sudarshan? I will take that as a no. So all that is left for me to say is thank you so much, everybody, for joining us. If you'd like the recording, have a look on our YouTube channel that I've just put in the chat. Sometime next week it will be there, or have a look at it, look out for it. I will be putting it in the follow-up post to today's event as well on LinkedIn. So if you follow the London Java community, you'll see it there too. And so the only other thing to say is thank you so much, Soumya, Sudarshan, Aditya and Alex, for speaking to us today. It's been really fascinating to hear what you've all spoken about. Great to hear from you, and thank you everybody for joining us. I hope you have a fantastic weekend, and we'll see you at the next LJC event. Thank you so much. Have a great one.
Thank you. Cheers.
Bye.
Bye.
Bye.